in this lecture, we will look at the graph of the function y equals secant 2x plus pi over 6 minus 1. You know, this quantity 2x plus pi over 6 is inside secant. And then secant of this quantity, then subtract 1. This one looks a little bit complicated, but you know, it's not really. First of all, we got to figure out the period. We know secant has the period 2 pi. Okay, and you know secant is the reciprocal of cosine. So cosine has the period 2 pi, and secant will have the period 2 pi. But here there is a coefficient 2, so will be 2 pi divided by this coefficient. Okay, here and here. So the period from 2 pi comes to be pi for this one. Alright, that's one thing. We know the period. So the period is smaller than 2 pi. Now the second thing is about phase shift. You know, the above function secant 2x plus pi over 6 can be written as secant 2 times quantity x minus negative pi over 12. We know down here is that minus is going to be positive. 2 times x is 2x. 2 times positive pi over 12. You know, these two cancel one factor. There is a factor 2 here, so it's going to be 6 denominator. It goes back to there. So the above one can be written like this. The reason I wrote in this way is that it minus a negative number. It means that the phase will shift to the negative direction. Okay. Previously, you know, if it minus a positive number, then it will shift to the positive direction. You see down here, this example is minus pi over 2 minus a positive number. So the point was here shifted to here. Okay? Yeah, recall that we have 2 typical values. Pi over 2, 3 pi over 2. Okay? Previously was 0 and pi. So minus a positive number, the shift direction will be to the positive direction. And then down here is minus a negative number. Minus a negative number, it will shift from the origin to the negative direction, pi over 12. That's the one thing we want to be careful. So here the phase is shifted pi over 12 to the left. And another thing is that it's not pi over 6 to the left. It's pi over 12 to the left. You have to pull these two out. Why? I will show you here. Okay, I will show you here. But you know, that's the reason. 2 needs to be pulled out, and then the constant left over will be the phase shifting. Okay, and here are the reasons. I will show you in a minute. Now, after you get the whole value, each value of secant needs to subtract 1. So the graph is shifted vertically with 1 unit down, because every value will be subtracted by 1. Okay, here are the details. Here are the details. we want to do is that since we know down here is that the phase is shifted negative pi over 2 means to the left, so we will start with this one. Okay, algebraically, let's see if this is really the case or not. When x equals negative pi over 2, now 2x is negative pi over 6 because 2 times the quantity. And then 2x plus pi over 6, you have a pi over 6 plus negative pi over 6 because 2x is negative pi over 6. You cancel each other, pi over 6, negative pi over 6. You then have a 0. So the big quantity 2x, bigger quantity 2x plus pi over 6 is 0. Then secant 0 is 1. Okay? Secant 0 is 1. That's what we need to remember. Previously, you need to have what? This is the graph of secant. When x is 0, you have 1. 0, 1. And then pi, negative 1. Okay. Now, so algebraically, we know negative pi over 12. This one, you will get 0. Alright. Another one, typical value is 5 pi over 12. Now, let's see algebraically, previously we have a 0 pi at 0 pi at 2 typical values. Now we have another 2 typical values. One is this one, another is 5 pi over 12. Why? Here is the case. 2 times 5 pi over 12, then we get 5 pi over 6. Okay? 2x equals 5 pi over 6. You add pi over 6. Pi over 6 is 1 in front of pi. So 1 pi 6 plus 5 pi 6. You have a 6 pi 6 over 6. 6 pi over 6. 6 cancel each other. So you then have a pi. Okay, so big quantity 2x plus pi over 6 is pi. Then secant pi is negative 1. So you see right here. Okay, secant pi is negative 1. 0, 1, pi, negative 1. 0, 1, pi, negative 1. Again, basically, I want to emphasize is that those two are the same with the previous one. Okay, with those two rows. Alright. Then secant 2x plus pi over 6 is 1. We have to subtract secant 2x plus pi over 6. This one is 1. We have to subtract 1. So for this case, we get 0. Then for this case, secant 2x plus pi over 6 equals negative 1. You then subtract 1, you have negative 2. So that's why the graph is actually shifted 1 unit down because of subtraction here. Okay. Here is the picture. Negative pi over 12. You put it right here, you then have a 0. Okay? And the 5 pi over 12, 5 pi over 12, you have negative 2. So you see right here. Okay? 5 pi over 12, and then negative 2. 1, 2. Here we should have negative. Okay? And here is positive. Yeah, so basically it was here, then negative pi over 12 to the left, and then 1 unit down. And then previously was somewhere here, pi over 12 to the left, and then 1 unit down. It goes here. Alright, yeah. This would be the picture. This was the picture. And here there are more reasons, there are more details about those asymptotes. And here we got to check, we know those values are the meaning. Then how about those three values, asymptotes? If you want to study those three values, you got to look at actually this picture. Okay? This picture is y equals secant 2x. Yeah, without phase shifting pi over 6. Previously, for secant, the graph is like this. It's negative pi over 2 for this one. And then for this one is pi over 2. And then 3 pi over 2. Those 1, 2, 3. At this place, the period was from 0 to pi. The one period is 2 pi. This is for secant x from here to here. Now, if you look at all those three places, negative pi over 2, positive pi over 2, 3 pi over 2, if here there were coefficient 2, then everywhere needs to be divided by 2. Okay, so this place needs to be what? Pi over 4 and negative, and then pi over 4 positive. Okay, and here will be 3 pi over 4, and here 2 pi divided by 2 will be pi. So that's why, that's one period. That's basically I want to say right here. You see, down here for this picture, secant 2x, instead of negative pi over 2, right here, you see, negative pi over 2, you have a negative pi over 4, right here, for this one. Here is pi over 2, okay, pi over 2, the first asymptote to the close to y axis, and then pi over 2, here would be pi over 4. The second one, starting from here, 1, 2, it was 3 pi over 2, then down here, 3 pi over 4. Okay, so secant 2x, you will get everywhere divided by 2. Okay, so secant 2x has this kind of picture. Then you do the phase shifting pi over 12 is the whole picture to the left, to the left, to the left with pi over 12 units. So basically, previously, let's look at the one here and all the one here. Pi over 4 shifted to the pi to the left with pi over 12 units is pi over 4 subtract pi over 12. Pi over 4 minus pi over 12, what is that? You want to make denominators be the same, so you times 3 for both numerator and denominator. 3 times 4 is 12, so they are the same. 3 times pi is 3 pi, minus pi you have a 2 pi. So 2 pi over 12 is pi over 6. That's how we got this one. Okay, and for the other two, I have a notes here, so you may enjoy yourself. Alright, so this is the picture. There are 3 steps. First, period. Second, phase. Third one, 1 unit done. And 2 critical values we often think about. For the details of the asymptotes, you want to compare those two. Okay? Please review this lecture. I'll see you next time.